In this class, we're going to take a look at composite functions. So just like in the everyday use of the word composite, we're talking about taking functions and sticking them together. So composite means take things and stick them together to make a new thing. So in this class, we're going to be working with two functions, so usually an f and a g, and they're going to come sort of in pairs. And we're going to take these functions and we're going to merge them in some way to make a new third function, which we call the composite. So before we get into look at the actual technique, which is fairly straightforward, let's think about the notation for composite functions. So assuming you've got an f and a g, but they could be any letter. So maybe just to mix it up a little, we'll actually put like an h function in there because they're not always going to be f and g. So how do we actually write the composite? So if you've got an f function and a g function, then you would write the composite as f of g of x. So notice the way that I said that, f of g of x. And notice as well, or know as well, that f of g of x is not necessarily the same as g of f of x. So when we get into the examples, we'll maybe work a couple of them both ways. So we'll do f of g of x and g of f of x. That's a different order of the composition. So if you compose f with g or g with f, on rare occasions you might get the same answer, but generally you can expect a different answer. So you've got to be attentive to the order of the composition. There's another notation that's sometimes used as well, which is f of g of x, like this, or if it was the other way around, it would be g of f of x. So you may see that in textbooks. It's unlikely to see that you'll see that more often than this one. This tends to be the standard notation. This can be a little confusing for students. I personally don't like this notation, so we're going to go with this notation up here. I think it's clearer and it allows a process within the algebra by the use of the brackets, which is clearer, I think, as well. So we're going to stick with this one, but just to let you know, you might see it like this as well. So turning to the first example, we're going to start by making the composite f of g of x. So f of g of x. So the way that I like to teach this is just to take the inner function, which is g of x, and replace g of x with what g of x actually is, which is the function 5 plus 2x. So 5 plus 2x. So I've not really done anything mathematical there. I've just replaced the g of x with what g of x is. Now we need to think a little about what this means. Well, this means that you're taking this expression, 5 plus 2x, but you're applying the f function to it. And what is the f function? Well, it's a function that says take your variable, your input value, and do 2 plus that variable. But our variable now is all of this. This is the thing we're putting into the f function. So what we have to do is apply the f function to that. So that's going to be 2 plus, but it's not 2 plus x, it's 2 plus all of that. So effectively what we're doing is replacing the x in the f function with 5 plus 2x. And that's really all that composite functions come down to is replacing some of the terms in the expression. So it's going to be 5 plus 2x. So notice that I've mirrored the structure there of the f function. It's 2 plus something, and it's 2 plus this new something, this new variable. So we can take a line now just to tidy up the algebra by combining the number terms. So we're going to get 7 plus 2x, and that's us done with that one. So just for illustration, let's go ahead and work out the composite the other way. So we're going to do g of f of x. So just going through the same technique. The technique should never really change for these. So just replacing the f of x part with what it is, which is 2 plus x. Then look into the g function and saying, what does the g function do? Well, it says do 5 plus 2 times your variable, whatever the variable is. Our variable is now 2 plus x, so we're going to do 5 plus 2 times 2 plus x. So use of a bracket there is useful. So it looks a little more complicated, this one. It might just need an extra line of working to multiply out the bracket. 2 times 2 is 4, 2 times x is 2x, and then just tidying that by adding the numbers together and we get 9 plus 2x. So you can see there the difference, the way the composites have come out. So that was the composite one way, that was the composite the other way. Okay, so not too bad as a technique. It's kind of with two functions and with fairly easy linear functions like these ones, it's quite a straightforward technique. As you move to different function types, it can get a little more complicated. You might need some more lines of work in to tidy up the algebra, but it is really just simplifying the algebra. The technique, the way you'll get started, should never really change. Okay, so let's have a look at this one here. So we'll just do it one way this time. Let's maybe do f of h of x. No, let's do h of f of x. H of f of x, I think that will be more interesting. Okay, so just going through the same process again, we're just going to replace the inner part, the f of x, with what it actually is, which is x minus 3. That's always your first move, and then just thinking, okay, what does the h function do? It takes your variable and it squares it. Our variable is x minus 3, so it's x minus 3 all squared. Or another way to think about it, just look at the h function, and everywhere you've got an x, replace that with x minus 3. Whatever goes here, you're just replacing that in the function. For this one, you could leave it like that, but you'd probably be expected to multiply at the brackets. If you do that, you would get x squared, you would get 2 negative 3x's, giving you a minus 6x, and you'll get a plus 9 on the end. So that one ends up being this sort of trinomial format. Okay, so that's a fairly common thing to have like a squared in one of the functions. Right, let's look at the last one. So the last one's got a slightly different format. It's got a trig function in it, but that's not unusual either. You'll probably see quite a few trig composite functions when you move into other classes. So let's maybe do this one both ways, just for illustration. So we'll start with f of g of x. So just taking the g of x and putting that into the bracket. So g of x is 4x, so it's going to be f of 4x, like that. Looking at the f function, which is a little different this time because it's a trig function. So it's the function cosine of x, so cos x. But that just means that we replace the x with whatever we've got in here, which is 4x. So that comes out to be the cosine of 4x. So just going through that same process again. It might take a while for you to get experience of these different types of functions, because when you compose them, you can see they're all coming out to be slightly different looking things. They can come out to be really wildly different formats. So you just need to see enough of them to have that expectation. Okay, so finally, let's have a look at g of f of x. So we expect this to be different than the cos 4x that we just got there. Just going to highlight that one. That was our answer. That was the answer there as well. Okay, so going through the same technique again. So just changing the f of x to what it is, which is cos x. So putting the cos function inside the g function, applying the g function to it. The g function just says take your variable and multiply it by 4. Our variable is now cos x, so we're just going to multiply that by 4. So we just get 4 cos x. And that would be the final answer for that one. So it's a fairly short process taking a composite function. It should never really be much more than 3 or 4 lines of working at the very most, sometimes just a couple of lines of working. Quite a straightforward technique, but any new technique takes some time. A lot of students do get confused by the first move. Usually simplifying the algebra is quite straightforward, but yeah, that first move can be a little unusual. If you're not used to merging functions, and why would you be used to them if you've never seen them before, then it's just a new technique to learn. So take your time with it, be patient. You might find you get a few of them muddled and mixed up to start with, but before long, it's a technique that will be quite manageable. And just try to get some variety of the types of functions that you're composing. So that's basically how you compose functions. Make sure that you understand what I've talked about there, and then check out some practice questions on that technique.